This is the 2.3 video. In this one, we're going to be proving lines are parallel, or maybe justifying why they're not parallel. So we're kind of going back to the same diagram over and over again. If we have two lines and a transversal, how do we know if those lines are parallel or not? What if we didn't know if they're parallel? Is there something or are there some things that would tell us that? And absolutely there are. So this is very crucial to get in your notes. You're going to use this over and over. So line M and N are parallel if one of the following things happens. Okay, if alternate interior or exterior angles are congruent, then you know the lines are parallel. And people do use this in real life. If they wanted to know if two things are parallel and maybe they're very far apart and it's tough to measure, they could draw a transversal, they could measure the angles, and then they would have their proof. So if those alternate interior and exterior angles are congruent, or if the corresponding angles are congruent, that would be proof that the lines are parallel. Or if those consecutive interior or exterior angles are supplementary. So none of this is new. This all came actually from the 2.1 lesson where we went through each of those, but we're kind of working backwards. In that lesson, we knew the lines were parallel. So then we knew that these things were true. This time, we are going to check to see if the lines are parallel. We don't know right away, but we're going to use these facts, these geometric ideas, to see whether or not the lines are parallel. So we're just going to go through a couple examples here, and it says decide if line M and N are parallel and explain why or why not. So I would just pause right now and get these diagrams drawn, and then we'll go through those examples. So here we go. Now you really don't have enough information just yet. I have to give you a little bit more information. So I'm going to tell you this. I'm going to tell you that the measure of angle 1 is equal to 140 degrees. And I'm going to tell you that the measure of angle 2 is equal to 138 degrees. Okay, so is that enough information to decide if the two lines are parallel? Well, the first question is what kind of angle pairs or what kind of angle pair is angle 1 and 2? Well, if we draw the letter F, we can see that we got this guy and this guy are kind of on the inside. And it said angle 1 was 140 degrees and angle 2 was 138 degrees. Now, those are corresponding angles. Corresponding angles. And if those two lines were in fact parallel, those corresponding angles should have been congruent. And we have an issue. They're not congruent. They're close, but they're not quite congruent. So we're going to say this. We're going to say M is not parallel. That's the parallel symbol to M because corresponding angles are not congruent. That was kind of a lot of writing. Try to shorten that up next time. All right, so in example 1, the lines are not necessarily parallel. All right, example 2. This time the information I'm going to give you is the following. I'm going to tell you that the measure of angle 3 is 140 degrees. And the measure of angle 4 is only 40 degrees. Uh-oh, is that a problem? It looks like those lines are pretty parallel. Oh, that's right, because angles 3 and 4 are consecutive interior angles. And consecutive interior angles should be supplementary if our lines are parallel. Okay, well, 140 degrees plus 40 degrees is equal to 180 degrees. So these lines are in fact parallel. We can mark them as parallel, and we can do this. M is parallel to N because consecutive interior angles are congruent, or are supplementary. All right. We'll just do a couple more here. On this one, I'm going to say that the measure of angle 1 is equal to 35 degrees, and the measure of angle 2 is equal to 35 degrees. Okay, is that enough information? Well, yeah, because we have the letter Z, they're on the insides of the Z, so those would be called alternate interior angles. So now we can say this. We can say line M is parallel to line N because, I'm abbreviating here, alternate interior angles are congruent. And that's enough justification. That's enough proof. If you know that alternate interior angles are congruent, then you don't have to do any measuring. You don't have to go check to make sure that those are the same distance apart, right there and right there, because you already have your proof. You already know that those two angles were congruent. All right, and then last one, I'm going to tell you that measure of angle 1 is equal to, let's say it's 37 degrees this time, and same with measure of angle 2. That one's also 37 degrees. Well, that seems good. That seems promising. This guy's 37 and this guy's 37. But hold on. Angle 1 and angle 2, those aren't any of the angle pairs that we've talked about in this lesson. We talked about them in Unit 1. Those are vertical angles. And vertical angles are always congruent, no matter what. And the reason why this isn't helpful is because angle 1 and angle 2 are both on line N. There is nothing attaching them to line M. We didn't even need line M to have angle 1 and angle 2. So there's not enough information. It is possible that those two lines are parallel. They may very well be, but we don't have enough information to prove that they are, because vertical angles don't give us any proof that two lines are parallel. All right, so that's it. I think you should write your own summary for this one. If there's anything that stands out to you that you want to add, go ahead and do that now.